right, let's jump right into the core question that is literally keeping technical founders and compliance officers awake at night. Can AI execute privacy compliance autonomously without creating massive risk? It's the ultimate tightrope walk, right? On one side, you've got the raw power of AI to automate everything at lightning speed. On the other, you have the absolutely terrifying liability of a rogue AI accidentally wiping out a user's data, or worse, sending a botched legal notification to a government regulator. So, welcome to this explainer on the DPDP compliance platform V5. Today, we're going to unpack exactly how one engineering team tackled this crazy tension between AI speed and human governance. We're looking at a serious architecture here, one that juggles multiple jurisdictions, from India's DPDP Act to the EU's GDPR. And we'll see exactly how they fundamentally rewired their entire system to prioritize safety over blind speed. Here is our roadmap for today. We'll start with the big autonomy versus governance dilemma, peel back the architectural layers of Platform V5, meet the 4 specialist agents, break down a really clever new machine learning pipeline, and then we'll wrap up with a radically transparent Project Scorecard. Let's get right into it. Section 1. Let's tackle the elephant in the room when it comes to autonomous systems. This quote, right from the project stakeholders, Devank and Anarit, honestly hits the nail on the head. AI agents executing compliance actions autonomously is exactly what makes this product different, but also exactly what makes it risky without governance. It is a massive double-edged sword. Sure, you want the system to read access logs, spot a breach, and draft a legal notification citing the exact regional law in under a minute. But high-stakes moves, like notifying a regulator or permanently deleting a data vault, there's no way that can happen without human oversight. The risk is just way too high.
So, what's their fix? It's the absolute centerpiece of V5, the human-in-the-loop, or HIL, approval queue. Think of it as a literal gatekeeper. High-stakes actions get parked right there in a pending_review state. A real human has to manually authorize it before it ever flips to execute it. This one structural shift completely transforms the platform from a sketchy black box AI tool into a rock-solid enterprise-grade governance engine. And it's smart, too. It uses strict role-based access controls, so you can't just approve your own generated actions. And it enforces SLA deadlines, so absolutely nothing falls through the cracks.
All right, Section 2, Anatomy of Platform V5. Let's look at how this gatekeeper actually wires into the broader software architecture. The whole operation is run by a LangGraph orchestrator, basically the central brain choreographing the AI, and it manages every single event through a strict 4-step lifecycle. Step 1, classify the request. Step 2, pass the consent gate. Now, Step 2 is fascinating. The platform verifies cryptographic hash chains in a consent ledger before it even thinks about processing personal data. If there's no consent or the consent expired, bam, reject it immediately, complete with a specific regional law citation. If it does pass, Step 3 routes it to a specialist agent, and Step 4 either executes it or punts it to that approval queue we just talked about. So what exactly is happening at Step 3? Let's jump to Section 3 and meet the AI workforce inside the platform. The platform relies on 4 distinct specialist agents. First up, you have the vision agent, handling CCTV and biometrics. And get this, it never actually persists raw biometric data. Instead, it uses this brilliant downscaling and upscaling trick to drop an image to a 10 by 10 pixel grid, making faces completely and irreversibly unrecoverable. Then you've got the breach agent for anomaly detection, the rights agent for user data requests, and the compliance agent, which spits out readiness scores mapped to specific regional laws. The rights agent is a perfect example of this platform's risk-proportionate design in action. Say a user sends an access request just to see what data you have on them. That's read-only. It's harmless. So the system just auto-approves it. But erasure and correction requests? Those are destructive. They actually alter or delete encrypted records in the vault. Because of that, the system unconditionally forces them into human review. It's not just blindly blocking everything, it's highly targeted, smart governance. Moving on to Section 4. Let's see how the breach agent got a massive technical upgrade to solve a major industry headache: alert fatigue. In version 4, the platform leaned entirely on a large language model to detect breach severity. And, well, you know how LLMs can be. They're a bit inconsistent. Asking an LLM to guess severity from raw logs over and over again leads to a ton of false positives. So for V5, they introduced a massive shift, a hybrid approach that uses a gradient-boosting machine learning classifier. It's essentially a super accurate, specialized statistical model acting as the very first line of defense. Here's how this hybrid setup plays out in reality. The agent pulls a 7-feature vector from the logs, looking at concrete data points like failed attempts and bytes transferred, and runs it through the ML classifier. If the classifier is 75% confident or more, boom, the system accepts that severity score right away. The LLM is totally skipped. But if that confidence drops below 75%, it falls back to the LLM to reason through the anomaly. It even logs exactly which mode it used, which is a real game changer because it solves the false positive problem with empirical, testable data that you can review later. The absolutely crucial takeaway here is that the severity score actively dictates the workflow. If the system catches a breach but scores it as low severity, it can just auto-dispatch it. That saves compliance officers from drowning in meaningless alerts. But the second something is scored medium, high, or critical, it hits a brick wall. It gets forced straight into that human-in-the-loop gatekeeper. The AI might draft the regulator notification, but a real human has to click send.
Finally, Section 5. Let's pull up the project scorecard and look at the cold, hard facts of this V5 delivery.
Out of the 14 original requirements they set out to tackle, a solid 8 were completely, fully implemented. And we're not talking about just checking a box on a to-do list. These are backed by real code, complete with automated regression coverage in the test suite, making sure things like the ML classifier and the right state machine don't magically break on the next update. Looking at this status table gives us an incredibly transparent snapshot of where the platform is actually at. They absolutely nailed the core stuff: the approval queue, the ML evaluation, and that complex multi-jurisdiction logic. They also successfully built alignment for the EU AI Act, handling prohibited practices and high-risk AI rules. But there are 3 partial completions and 2 pretty glaring technical gaps sitting right there in the not done column. And to their credit, the team is very upfront about this. Honestly, the most honest takeaway here is the V6 roadmap. Right now, the platform is running on an SQLite database, and let's be real, that is a huge bottleneck if you want enterprise production scale. Migrating to Postgres or Supabase is an absolute must for their next phase. Also, while they crush the EU AI Act stuff, the platform desperately needs India AI governance parity to match, especially since it's positioned as a DPDP first product. Oh, and they also need to rework that compliance agent to generate dedicated data protection impact assessments. As you look back at this platform's journey from risky autonomy to structured, verifiable governance, I really want you to ask yourself, is your own data infrastructure actually prepared for the regulations of tomorrow? Are you letting AI run the show unchecked, or are you building the necessary human-in-the-loop gatekeepers? Thanks so much for joining me on this explainer, and remember to always keep questioning how your systems are truly operating under the hood.